In this example, we want to show that the inner product of u plus v with u minus v, given by, that inner product is equal to the norm of u squared minus the norm of v squared. And here we want to use, because it's not specified, the dot product as the inner product. So the inner product of xy in this example is going to be x transpose y, because it's not stated. Okay. So we're looking for u plus v and u minus v. So let's let u be u1, u2, all the way to un, and v be v1, v2, all the way to vn. And so the inner product of u plus v with u minus v is going to be this dot product. So the first one, u plus v, the sideways vector, is going to be u1 plus v1, then u2 plus v2, all the way to un plus vn. And we're going to multiply that by our column vector, u minus v. So this is u1 minus v1, u2 minus v2, etc., all the way to un minus vn. So now when we multiply these, what do we get? So we get u1 plus v1 times u1 minus v1. So we get u1, let's write it out. u1 plus v1 times u1 minus v1. That's our first multiplication, plus u2 plus v2 times u2 minus v2, plus etc., plus un plus vn plus vn times un minus vn. When you open up all these brackets, you get u1 times u1 is u1 squared, v1 times u1 plus u1 times negative v1, those will cancel, and we get v1 times negative v1, that's the negative of v1 squared. And that's going to happen because you're multiplying a sum times a difference. You're going to get the same thing each place. So this is going to be u2 squared minus v2 squared, etc., un squared minus vn squared. And so if we collect all of our u's and all of our v's, we get a sum of these u1s. So u1 squared plus u2 squared plus u3 squared, all the way up to un squared, plus all of our, not plus, minus, because we're subtracting them all, our v1 plus v2 plus v3, all the way to vn, and each of these is squared as well. Now, this looks a lot like the dot product for u dot u. So this is u transpose times u, so the dot product for u, minus the same thing here. This is the dot product for v, so v transpose v. And of course, the norm of u is the square root of that dot product. So this is the root of, and we can rewrite this as the inner product of u and u squared minus the inner product of v and v, the square root of that squared. And this first guy is the norm of u squared and the norm of v squared. And so just by making that calculation, rearranging a little bit, we can show that the inner product of u plus v with u minus v is equal to the norm of u squared minus the norm of v squared.